So in this section, we are going to talk about different types of chemical reactions. The way to think about this is that there are many chemical reactions that are known. There are probably millions, probably more than millions of chemical reactions that are known. And because of that, chemists will often try to group them into different categories. So the idea is that different chemical reactions, even though they're different from each other, sometimes they have common features. So you can group them into specific classes. So here's the first class of chemical reaction. It's sometimes called a combination reaction. It's also sometimes called a synthesis reaction. Sometimes it's called a composition reaction as well. The idea behind this reaction, this type of reaction, is two or more things combine to make one thing. And what I mean by that is two or more materials combine to make one material. And this is my generic chemical equation for that. Over here on the left side of the arrow, we have two things, so it's two or more things, combining to make one thing. So material A plus material B, under some conditions, can end up being attached to each other. So that A and B are now one thing that is attached. And as a specific example of that is shown here, this is solid sulfur plus oxygen gas. If you mix them under the right conditions, they will make something called sulfur dioxide gas. But hopefully you can see that this chemical equation is a type of combination reaction because you start with two or more things and you end up with those things being attached to each other. You end up with one thing. That's an example of a combination reaction. The next type of reaction is basically the opposite of that. It's called a decomposition reaction. Here you basically have one material breaks apart into two or more materials. And the way that I'm showing it in general form is these two materials are attached to each other at the beginning. Under some special conditions, you can get them to break apart into separate materials. That's a decomposition reaction. A specific example of a decomposition reaction is shown here. This stuff here is called calcium carbonate. So if you take solid calcium carbonate, heat it up, you can make this material, which is called calcium oxide and carbon dioxide. So basically this molecule over here on the left broke apart into two other types of molecules, calcium oxide and carbon dioxide. And so this reaction here is one type of decomposition reaction. The third type of reaction is shown here. Again, I'm not showing you an exhaustive list of different types of chemical reactions. I'm just showing you some of the more common ones that are shown to beginning chemistry students. So this type of reaction is called a single replacement reaction. So the idea here is that one element kicks out one other element. And I'm going to show that with a little bit of an animation. So here's one element all alone. Here are two elements or materials that are attached to each other, and basically this material over here is going to kick out one of these pieces and attach itself to the other piece. So watch the animation. Element A or material A comes in, it kicks out J, and it attaches itself to B. And so this is sort of a visual for what's happening in a single replacement reaction. One single thing, I'll show it to you again, one single thing kicks out something else, and that something else ends up alone, and the original single thing ends up paired with one of the materials that was originally paired up. So, and my pop culture reference for this, for my on-ground students, and I might as well describe it to you here as well, is that in this case the A stands for Angelina Jolie, and this is Jennifer Aniston and Brad Pitt, and then basically Angelina comes along, kicks out Jennifer, and ends up with Brad. That is a single replacement reaction. So I probably need to update my pop culture references since this probably happened about 15 years ago, but I don't know who is kicking out whom these days, so I'll leave it at that. In more chemistry terms, the reaction is shown here. A is all alone at the beginning. J and B are attached to each other. Under certain circumstances, you can basically have A kick out J, A ends up with B, and J ends up all alone. This is a single replacement reaction. A more real-life chemistry example is this. Solid zinc plus this material here, this is aqueous copper chloride, that's what the AQ stands for. If you mix those two under the right conditions, zinc ends up kicking the copper out, and you end up with zinc attached to the chlorine and copper all by itself. This is a single replacement reaction. Double replacement reaction is similar to a single replacement, except you have two sets of materials and both sets have a partner. And then basically what happens is that there is a swapping of partners. So here S and H are together, F and B are together, and then somehow there's some swapping, and I'll show you with an animation. It looks like S and F are swapping partners there, and then you end up with F and H and S and B together. That's called a double replacement reaction. In equation form, it's shown here. S and H and F and B are together on the left side, but then they swap partners. F goes with H, and that's shown here, and B goes with S, and that's shown here. That's a double replacement reaction. Sort of a more specific example of a double replacement is shown here. Hydrochloric acid, that's HCl here, mixed with this material here, which is called sodium hydroxide. Under these conditions, the H over here with the Cl ends up pairing up with the OH. And the Na, which is also known as sodium, ends up pairing with the chlorine. So Na goes with the chlorine, and it makes sodium chloride, which is also known as table salt. And the H goes with the OH, and together they make H2O, because it's one H, two H's, and an O, makes water. And this is an example of a double replacement reaction. Basically, the H and the Cl and the Na and the OH swapped partners to make table salt and water. So that's a double replacement reaction. That's another type of reaction I'd like you to be able to recognize. Another type of reaction that I'd like you to be able to recognize is called a combustion reaction. A general description of a combustion reaction is shown here. You have some material, which I'm just calling A over here. It has to mix with oxygen gas. So oxygen gas is always O2. Material A plus O2 ends up having material A attached to oxygen in some way, and energy is released. So basically, there are a bunch of characteristics that are needed to make a combustion reaction. You need O2 gas on the left side of the equation. You need some material attached to oxygen on the right side. It doesn't have to be O2 on the right side. It could be AO, it could be AO3, it could be AO4. As long as the equation in the end is balanced, it's perfectly fine to have something other than O2 on the right side. You do need O2 on the left side, however. And the other feature is that the reaction will produce energy. So if you see those characteristics, O2 on the left, material A attached to oxygen in some way on the right, and energy also produced on the right, then that's a combustion reaction. Another way of thinking about it is some stuff plus O2 makes the other stuff, the original stuff attached to oxygen, plus some energy. Specific example shown here is this material is methane gas mixed with two O2s plus some heat will make carbon dioxide, water, and energy. And hopefully you can see that the pieces of this material ended up attached to oxygen. So the carbon ended up attached to some oxygen, and the hydrogens also ended up attached to some oxygen, and energy was produced. This is an example of a combustion reaction. This is a different combustion reaction, but again, it just sort of illustrates the point again. This is sugar. This is a formula for, well, you can think of it as a formula for glucose, which is a relatively important type of sugar for living organisms. Sugar plus 1 mole of sugar plus 6 moles of O2 gas will make, under the right conditions, 6 moles of carbon dioxide and 6 moles of water plus some energy. And this is also a combustion reaction. If you think about this in biological terms, some of you may recognize this. This is a general equation for respiration, or So basically, your body uses sugars like glucose. You breathe in oxygen. There should be a triangle here. You heat them up, and you exhale carbon dioxide. You also produce some water, and you also get some energy from the sugar. And so respiration, or the way that your body gets energy from sugar, is a type of combustion reaction. So I'd like you to be able to recognize these different types of reactions, the ones that I showed you on the previous slide. That includes synthesis reactions, decomposition, single and double replacement, as well as combustion reactions. The last section is going to talk about a couple of different types of reactions and conclude with something a little bit possibly more biological.